Hello and welcome everyone. Our today's question is vertical width of a binary tree. So we have given a binary tree and we have to find and return the vertical width of a binary tree. So what is a vertical width and how it is different from diameter of a binary tree? So let's suppose we have this tree and we go to the left side and we go to the right side and we subtract the rightmost side from the leftmost side and return the difference. So in this case, as you can see, we have height 2 here on the left hand side and 3 here. So we can say, so its answer is 6 and here the answer is 3. So this question is simple, and if you have solved this question, diameter of a binary tree, so let me tell you the difference, how it is different from the vertical width of a binary tree. So in this question, given the binary tree, return the length of the diameter. So what is a diameter? Diameter is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root, and the length of the path between two nodes is represented by the number of edges between them. So let's take an example. In this case, so this is the width, this is the diameter, sorry. So in this case, uh, in this question, it does not include the node itself, and it finds the left side and the right side. So left side we have two nodes and right side we have one node. So the answer is 3 here. So let me tell you the difference, how it is different. So I am taking an example here. So in this example, first to find the diameter of a binary tree. So what is a diameter? We go to left and then right. So in this case, we are finding the height. So overall height, what is the height? So as you can see, the height is 3 here, and on the right side the height is 3. So according to diameter, the answer is 6. But according to this question, vertical width, so let's find the vertical width. So the approach for this question, or the description says, first find the leftmost side and find the rightmost side. So the leftmost side is this only. So let's take this 0, and so we are going into left direction. So let's take -1 and let's take 1 here, and no other left direction, and here also no other right direction. So according to vertical width, the answer is 3. So that's the difference. So now let's find, let's build the approach. So first take this simple test case. We have this. So this approach is around the indexes. So for root, the index is 0, and we have to find the leftmost node and the rightmost node. So if we are going on to leftmost direction, I will subtract -1 from the id, from the parent id. So parent id is 0 and we are going left direction. So -1, -2. And if we are going on the right direction, 1, 2, 3, and let's fill other nodes also. So here we are going left direction, so subtract 1 from parent, and we are going right direction, so add 1 into the parent. So here we are going right, so add 1 to the parent. So this is the leftmost node. So we can say minimum we can find is -2 and maximum we can find is 3. So subtract maximum from minimum. So 3 and -2. So it will give 5. But according to this, the answer is 6. So we will add +1 because we are not taking the node itself, we are going direction wise. So this is the farthest left node and this is the farthest right node, and we have to take +1 also. So this, and one more test case, this, let's find for this. Nodes can be duplicate, we have to find the vertical width. So 0 -1, 0, addition, addition, here addition, 1, then subtraction, then subtraction. So -1 is the minimum is -1 and maximum is 1. So 1 -1, 2 plus 1 we have to add, the answer is 3. So that's all. Let's jump into the coding part. So here, if you check the constraint, the number of nodes can be 0. So we have not tackled this. So let's first write the base case. If root is 0, then return 0 directly. Else find a maximum and minimum. So maximum initialize to minimum and minimum initialize to maximum initially. Then find or just build a function for root and id. If root is null, then directly return. Else we are going on the left direction with id -1 and we are going on the right direction with id +1 and find the maximum. Maximum is equal to, we have to take the id and minimum. At the end, subtract minimum from maximum and add +1. So that's the overall approach. Its time complexity is order of n, and if you include stack space, it's height of the tree. And if you like this video, a click on the subscribe button is appreciated. And thank you all for watching this video.